are going to do a pretty basic interaction with ellipses, but enough you'll be able to recognize. Need help, Jacob? Enough that you'll be able to recognize their formulas and their orientation, be able to graph them. Foci, that's probably new for you guys. You know, if I have a point, and if I were to attach a string to it, and then follow that string all the way around, look how round that is. But it gives you a circle, right? If I've got one length of string, and if I was to take my pen and pull it all the way around, it gives me a circle. Well, what happens if I have 2 points? So this time I'm going to give you a round string. So here's a round string, or a loose string, but it's tied together, so it's circular. And you were to take your pen and stretch it as tight as you could and pull it. Guess what it makes? It makes an oval, or what we call an ellipse in math. So that's what the foci are, and we're actually not going to spend any time on that today. Oh my goodness, I think I'm going to choke. Excuse me, got a tickle. See if I can make it for the lesson. What do you think the minus h does here? Good morning. Yeah, it's going to move it right and left.
Flip this over and mark it up if you would.
You bet, thank you.
Thanks.
And the k would move that ellipse up and down. A and B can trade places, and that sounds scary when I say that. But A squared is always the largest number. And the largest number helps us decide which way that ellipse is oriented. So if a squared is under x, I know I've got this horizontal ellipse because the biggest number is right there. Vice versa, if the biggest number is under the y, that's what gives me this nice, tall, we call it a vertical ellipse, okay? This ellipse happens to be centered on the origin, right? We haven't moved it left or right or up or down. And I want you to look at this length right here, from center to the vertex over there. How far is that? It's kind of hard to read those numbers, but how far is that? I've got a 1, 2, 3, 4, I think it's 5, right? I think we're counting by twos here. It's 5. So that means my value of A is 5. From center to the edge is 5. All right, let's do the same thing on the y-axis. Remember, it's counting in twos, so I'm pretty sure that goes through the 3. Yeah. So my value of B is 3. What is the equation of the ellipse? I'm not moving left or right or up or down, so I know it's x squared plus y squared, and I know it equals 1, and I've got to figure out what goes underneath the x and the y there. So under the x, because we've got this horizontal orientation, it says a squared. Our a was 5, so that would be a 25. Y squared, our distance, our b is 3, square it, and you get 9. Maybe we will graph and label the foci while we're here. C squared, and I'm just going from this formula right here. c squared equals a squared minus b squared. 25 minus 9 is 16. Take the square root of that. So c is 4. So from my center, 4 away, 4 away. If I was to have that loose string and pull it tight all the way around, that is the ellipse I would get. Emma?
So like on the one that was asking what is the equation of the ellipse, like what about like the h and the k? Are those, do you just not need to put those in the equation?
Where are we centered?
Oh, okay.
At 0, 0.
Right, that makes
Right?
sense.
So minus h and minus k, we're just taking away 0.
Okay.
That makes more sense.
Good. Good. Again, where's this one centered? The second one. 0, 0. So are we going to have an h and a k? We do, but it's 0. So it doesn't change the look of that equation at all, right? Now, we've already talked that our largest number is going to be under the y. So what's my value of a? Again, that's counting by 2's.
5 again?
5. The value of my b is, what a coincidence, 3. But I've got to pay attention. X squared plus y squared equals 1. Where does the 25 go and where does the 9 go?
And then obviously places.
Yeah, 25 goes under the y this time. And the 9 goes under the x. And it changes that orientation. I do want to show you how your Alex tools work. And there's also one that has some algebra we'll spend some time with. So for the first couple we do together, you're just going to be watching for the most part, and you'll say, oh, okay. But then the last one that we do, I'll want you to, wow, I can't have that there and be that. Sorry, that's going to be so tiny, you guys. I'll have you take notes on the last problem we do, because completing the square has been a long time ago. Okay, so let's start with, let me write some information down, I guess. Where is the center of our ellipse? Remember, it was x minus and y minus, so it's always going to be the opposite of those signs, right? So where's my center? At -3 and 3. It's a good idea to kind of think about what it looks like. Is this going to be a horizontal orientation, or is it going to be tall, a vertical orientation? Biggest number is under y, yep, so we're going to have a vertical orientation. So distance here is not 25, that's a squared. So what do I do? 5. I take the square root of it. Square root of 16 is 4. Now watch how friendly this is. I grab this ellipse tool right here. That's all I have to do. The first thing I do is find the center. So I'm going to take it over to 1, 2, 3, -3, 1, 2, 3. And I place it. The next thing it wants me to do is place. We always go horizontal first, if I remember right. So now from here I'm going to go 4. 1, 2, 3, 4. And then I'm going to go from that center again. What was my distance from the center? 5. So 1, 2, 3, 4, 5. It's that friendly. We'll do another one, so we're good at it. I was looking for, I've got to check it if I want to do the try another, don't I? All right, where is the center on this one?
2, -2.
Opposite, good. 2 and -2. My distance on the x-axis is 4. The distance on my y-axis is 3. Any questions with how I get those numbers? All right, so I grab my ellipse tool. I'm going to place the center. 2, -2. What's my distance on the x? 1, 2, 3, 4. From my center, uh-oh. I accidentally tapped the screen. Got to start over. Look at that. 2, -2. Distance on the x is 1, 2, 3, 4. Distance on the y is 3. It's pretty friendly, isn't it? Okay. So, of course, they're not going to stay that friendly. You guys know that by now. You're wise in the ways of what math does to you. On the next problems, you're going to need to do a little calculation. Okay, I want you to look at that equation. Is it too tiny? Do I need to write it larger? Okay, I will write it larger. We've got 25x squared plus 9y squared equals 225. That does not look like an ellipse equation, does it? So we have to do some work. I want you to look at your journal. What does an ellipse always equal? 1. What do I have over here? A 225. What do I have to have there? A 1. So what would it make sense to divide by?
225.
So if I divide by 225, 225, now I've got to reduce those fractions. How many times does 25 go into 225?
9.
Lovely, that's a pretty number. I like numbers I can take the square root of when I'm graphing ellipses. Plus, so 9 reduces with 225, it would be 25, right? Now that equals 1. Where is my center?
0, 0.
0, 0. So I grab this guy, place the center. All right. Distance on the x-axis is how far? I didn't take time to write it down a second ago. Remember, that is squared, so what's my distance on the x-axis?
3.
3. 1, 2, 3. What is my distance on the y-axis?
5.
So again, from my center, 1, 2, 3, 4, 5. Okay, well, a little work, right? But not bad. What would I need to divide this one by? 144. And let me see, that's the same thing, divide by 36. I'm thinking I took that out of your homework. Let me hurry and double check. I changed it this morning and I'm in student view, but it's showing that I didn't take those out. So let me look. I was going to save them for tomorrow. I just want to double check I did that. Oh, no, it's there. I think I do want to show it to you, and we'll see where we go. First thing we need to remember is how to complete the square. If I have x squared plus 8x, I want to have something right there that would make this so I can factor it. And I'll remind you how to do it. You'll be like, oh yeah, okay, that's what complete square means. So we take half of this number, which is 4, square it. 4 squared is 16. That means I can factor this. What are two numbers that multiply to be 16 but add to be 8? 4 and 4. So that can be rewritten as x plus 4 squared. That's completing the square. I'll do that one more time. If I have x squared plus 16x plus half of that middle number is 8, square it. 8 squared is 64. Okay. What are two numbers that multiply to be 64 but add to be 16? 8 and 8. So this is an x plus 8 and an x plus 8. Some of you can skip this step, and that's awesome. So I can write it like that. That is completing the square. All right, let me write this equation a little larger. I've got 25x squared plus 9y squared plus 200x, oh my goodness, plus 54y plus 256, and that equals 0. That doesn't look like an ellipse equation at all, does it? So what I want you to do is group your x's, 25x squared plus 200x. We're going to group our y's. And we're going to put this guy on the other side. Let's wait for you to get caught up in notes. All right. I am going to work just with the x's. Do they have... Does 25 go into 200?
Yeah, 8 times.
8 times. So I'm going to factor out that 25. So this is x squared plus 8x. Leaving some space. Now I'm going to do the same thing with my y's. Does 9 go into 54?
6 times.
All right, I'm going to factor out the 9. Why does that keep blinking? Leave some space. And we've got that equals negative 256. Got your calculators handy? We're going to need them. We're going to complete the square. Half of 8. Square it. Okay, I can't just go around adding things to equations without doing it to the other side. You guys know that. But I put that 16 in a set of parentheses, didn't I? What's in front of that set of parentheses? So I didn't add 16. I added, by putting it where I did, a 25 times 16. What's 25 times 16? Okay, so I changed the value of this equation by 400, just barely. So if I added 400 on the left, I need to add 400 on the right. I wish I had more room right there. I'm sorry, I got so messy. All right, same thing here. We're going to complete the square in the y's. Half of 6. 3. Square it. All right, so by putting that 9 in the parentheses, I changed this by a value of 81 plus 81. We're going to clean this up now. We'll take all the steps. Give me two numbers that multiply to be 16 but add to be 8. 4 and 4. So I'm going to write x plus 4 times x plus 4. What's the shortcut there? Can I just write x plus 4 squared, right? Okay, let's do the same thing with the y's. Two numbers that multiply to be 9 but add to be 6. 3 and 3. So I'd write y plus 3 times y plus 3. So we're going to do a shortcut, and we'll just say y plus 3 squared. Somebody calculate that for me over there.
25. Yes, 225.
325?
225.
2. Oh, I was like, 325 is not a number I want. Good. All right, we're getting warmer. We know this is an ellipse because it says graph the ellipse. What's this supposed to equal?
1.
So what do I need to divide by?
225.
All right, we're
Or so you're
dividing.
just getting it back to the hours.
Yep. All right, so we've got x plus 4 squared. 25 goes into 225 how many times? 9 plus y plus 3 squared. 9 goes into 225 how many times? I better erase that because I've got to grab that ellipse tool right there. Grab my ellipse. Where is the center? Back to where we started today. Where's the center? Yep, opposite. -4, -3. So 1, 2, 3, 4, 1, 2, 3. Distance on the x. Square root of 9 is 1, 2, 3. Distance on the y. Square root of 25 is 1, 2, 3, 4, 5. That's a whole lot of ooh, huh? That's the last 2 problems in your homework. They're going to take some work and some practice, and that's okay. I anticipate that. If I need to go through both of them with you, I will. Okay? So do the friendly problems first. Breeze through 1 through 6. And then we'll work on